Lesson 8.7. Last lesson, official lesson. Only day 1 though, we still have tomorrow.
Who cares?
Of your high school calc career.
Party!
Okay, so lesson 7 is our 3rd lesson of volume. Okay, this is still revolving, so we're still going to be talking washer and disk method. But the catch today is that instead of revolving specifically around the x-axis or y-axis, we're revolving around other parallel or horizontal lines. So you might revolve around something like x equals 2 or y equals 5. Okay, so we're revolving around other lines. So it's just kind of a matter of how does that change things up. Okay, so still disk and washer method, just other axes. So we want to explore volumes that are revolved about any line other than the x or y axis. You should feel comfortable and basic understands that if we rotate about any horizontal axis, then the cross-section area will be in functions of x. Okay, so think about this. A horizontal axis is something that's parallel to the x-axis, right? When we rotate around the x-axis, we were working in x's. If we rotated about the y-axis, or in other words, any vertical axis, then we're going to be working in terms of y's. Okay? So, I guess I had an extra slide, so I pulled it up. So let's look at and kind of generalize some of how these can work. Okay? How our setup changes a little bit here. So, to rotate about a horizontal line, which they're calling the horizontal line y equals c, okay, so c being the whatever that number is, express r outer and r inner as functions of x and integrate along the x-axis. So what we're going to do on these 4 is we're going to write the general form of the volume for the area r, where any cross-section is perpendicular to the axis of revolution. Okay? So, the idea here, as we look at this first example, we're going to be rotating about that axis right there. Okay? So we're not rotating about the x-axis. We are rotating about x equals, or y equals c. It is, isn't it?
Oh, I was like, what's going on in here?
Ooh! That was some nice bright.
Broken right now. Not the windows, like the blinds open. The blinds.
I don't know if I want that.
Oh, there goes the sheriff. That's neat. You know, I have to go. I guess you got a new car. I do too. After this class.
The Harry apartment.
Oh, I was like, what's going on now?
Apartment, please report to the high school.
It's like, dang it, I haven't been on my phone, I haven't been on my computer.
That you
No.
passed there for a second.
I know, like that brief moment of crud. I am going to pull up my email so I can glance over here and see. Because the last thing we got was we're at level 2. Okay, so yeah, I don't see anything. And I mean, it's a thunderstorm. It's red coming through, but
Yeah.
there's
We
not.
live in Indiana.
Well,
Yeah, it's gonna be 40 next week.
So,
you say that and
You're kidding.
yeah, it's gonna be the. Why do you think we have?
possible snow Monday.
You're kidding.
Stop.
me.
Guys,
That's what I heard.
Silly goofy joke.
Okay,
It's false.
Hey, if it is, I'm going to be
okay, guys. I've got to get us focused. I know, easier said than done. Here we go. Okay. As we are rotating about this axis, okay, we're rotating about this axis, we have to think about, well, first of all, let me ask you a question. Disk or washer method?
Washer.
Wash this.
Washer.
Yeah.
But there's here on that.
If we're rotating
Oh shoot.
this
We're
purple
rotating around
section
that.
There's a whole.
around this line, there's a gap, yes?
Yeah, wash it.
Okay.
All of them will be
So-
washer, right?
No.
Probably, honestly. Okay, so we're rotating about this piece here. Now, I want you to think big R, little r. Big R is your distance farthest away from where you're rotating. And then little r is your distance closer to what you're rotating. So in this case,
Excuse me.
Would that be big R is the x-axis?
big R is the distance from y equals c to the x-axis. That is big R. What is little r then?
The distance from that to the curve.
The distance from y equals c to the curve, which I think in my notes, that curve I'm going to call f of x. I mean, officially we can say y equals f of x. Okay? Now, with that in mind, make sure I have all the pieces here I need. We want to find what big R and little r are. That, you know what I'm trying to say. Okay, we want to find big R and little r. Now, as we look at this, okay, what kind of distance does big R have? Big R has a distance of what?
Y.
Okay, and I'm going to go with, okay, so yes, they're all y's, but specifically this distance, because what is this? This x-axis is 0, yes?
Yep.
It's going from 0 to c. So big R is going to be a distance of c. Okay?
Right.
And you can think of it if you want as c minus 0. But that's just c, isn't it? Okay? Now, little r. What is it, the distance?
Would it be like C2?
No.
That's what I was thinking, like C1, C2.
What's the distance here? It goes from what to what?
C to F of X.
It goes from c to f of x.
C.
C is bigger, yes, because c is up. And so it's going to be c minus f of x. Okay? Now, we're ready to write our volume. Okay, write our volume integral. Go with what you know.
Pi times the integral.
We're using pi all pi. Good.
Pi times the integral from
A to B?
a to b. You guys all with us on that one, right?
Yeah.
Now, this is a washer method, right? So if this is a washer method, what was our setup yesterday?
R
C
squared.
squared minus.
Big R squared minus little r squared.
Okay. So you guys are all talking different, but yet the same, yes? Big R squared minus little r squared. So my big R is,
C.
so c squared minus little r, which is c minus f of x, quantity squared,
Dx.
and then dx. Okay? Yes, there's quite a bit of rain falling now. The rain is here.
So after this hour,
I hope this is
See, what you're hoping right now is that all this, the big rain comes through right now.
Yes.
So you're not
Really
being
hope my
poured,
windows
you're
are
just driving through all the puddles.
And my son
And that's
knows.
fine.
I really
That's
hope
fine.
everything's
Yeah, just slow down for the puddles, please. Okay?
Yeah, puddles
You
are
don't know what
scary.
they're playing.
I hope
Yeah.
my sister takes in the dog.
Okay.
God, I hope my windows are closed.
Here's your setup. Okay? We're done with this one. That's all we're setting up right now. Are we good with that?
Yeah.
Okay. Let's look at the next example.
It'd be almost the same thing.
Almost.
Very
Except
close.
it's an addition sign.
Yeah.
Not.
It's flippy flopped.
No.
Okay? So,
Or, yeah, it'd be an addition.
yeah. So realize we're rotating about y equals c right here, yes? So we are rotating about a line below it.
Another
Okay?
washer method.
With this in mind, is this still a washer method?
Yes.
Yeah. Okay. So just, as we're setting these up, we're thinking about that. Let's look at big R and little r again.
Big R is now to the curve.
Okay. Big R is the distance from between the curve and the line, yes?
Yep.
Now, the difference is on this one, what's on top? And I'm going to call this curve f of x again. So big R is going to be f of x minus c. And the difference is it's because c is below Okay, since this line is below, that makes this, we have to think about C being negative, a negative value, because it is below the curve we're rotating.
You're not just adding it to it because there's more.
No, because how do we find the distance between two things?
Subtract them.
You subtract them.
So you just flip them.
So what?
You just flip the C minus fx and the fx minus C.
Right. Now, what's little r?
Negative C.
Yeah.
I just have C, and I'm trying to decide how I want to go about this, because
Back in the shackles.
oh, you know what? There's my mistake. I can't read my own writing there. That's where okay, so I misled you. I would never do that, right? Okay. I mentioned, but then I forgot about it. Because C is below here, we think negative value. Okay, so with that in mind, this should have been f of x minus negative C.
So plus C.
Yeah, I'm going to write it as minus negative C here for right now. Okay. With that in mind, if we talk about R being C, realize that's because it's going to be 0 minus negative C. Okay, and we're doing this because it is below there. Okay, sorry. I overlooked my... There's that tiny little negative there. Yeah, they look together. Okay. We have the information we need to set up, I think?
Yep.
Okay, volume is what?
Pi times the integral of A to B. F of x plus C quantity squared.
Minus
Negative C squared.
C squared?
Dx.
Yes.
So that's not negative C. R is not negative C. Or it's just C.
It would be 0 minus negative C.
Oh, okay.
Because we're thinking about C as a negative value. And that's what I have, what, line is below, so y equals C is a negative value. That's the comment I have in my notes here. When the line is below, then that's going to make C a negative value. Because in all honesty, it's usually a negative number when that happens. Okay. Okay, did we get it all? I think we did. Okay. Ready for the next one? Okay. What's different about this one?
There's F of x and G of x.
Yeah, there's f of x and g of x. We're no longer along the x-axis, okay? We've got two curves. So this one I tried to throw in and thinking, okay, you're really thinking 0 minus c or c minus 0 for that other piece. Here we have to use f of x and g of x. Of course, we are rotating around that line y equals c. Big R is between what and what?
G of X.
C and G of x.
So what'd you say?
G of x minus C.
C minus G of X.
Oh, yeah.
Yeah. And then little r,
C minus F.
it's the distance between c and f of x. So c minus f of x. Keep forgetting to label big R and little r. I write them in, but I'm not labeling them. I think we have everything there, don't we?
Yeah.
Okay. And again, when we do that c minus fx, c minus g of x, we're thinking upper minus lower, right?
It's still Walker method.
Okay. Yep. And as someone said, they all end up being Washer method, but I'm still trying to get you guys to think about it because that's where, you know, we have to do that. So V equals
C minus G of X quantity squared.
Pi times b.
Oh yeah, I remember that.
okay, pi times the integral from a to b. Now I've written mine down. I'm going to do one big bracket and then in parentheses c minus g of x
Quantity squared
quantity squared and then
minus quantity of C minus F of X squared. dx.
I'm gonna in that bracket and then dx. Okay. You probably see or know what's going to change up here. Okay. Now, C is below, yes? Okay. Where's big R?
C to fx.
How are we going to write big R?
F of x plus g.
For the purposes of what we're doing, I'm writing it as f of x minus negative c at that point. Yes, it's plus c, but I just want you to think, why is it plus c? If that makes sense. Little r? G of x minus negative c. Okay. Okay. I assumed after last time, so no one wanted to tell me I'm just supposed to write the first two pieces.
Yeah.
Okay. And
F of x plus c quantity squared minus g of x plus c quantity squared dx.
I think it's literally already done.
I'm going to say, that piece is done. I'm not sure I'd say we're done, but there's a nice little red strip heading towards us when I looked at lunch. So that was probably the red that just went through. Okay.
We don't want to be sitting at lunch. Is it going south?
I don't know that I ever put the radar in motion. I just looked west of us to see, you know, and that it was a tall red strip. So it wasn't wide, but it was tall. So it was one of those, it was guaranteed to hit us unless it dissolves between Logansport and here. So.
Okay. Logansport.
Yes.
I am extremely directionally challenged.
I know. I'm mentally challenged.
Okay.
I should probably just.
Examples.
It's probably
Okay. Y equals square root of x, y equals 0, and x equals 4. Those are the pieces that bound our region that we're going to be rotating about the line y equals 4. Okay? So with that in mind, that means that y equals 4, yes. That's the line. So we're rotating about,
I was on the
okay.
It was y equals 4 in one of the lines that you drew. It was about x.
Well, no. I think you, did you flip a page too far, I'm guessing? Okay. Oh, you really flipped a page too far. Okay, so we're rotating about the line. Y equals 4. The graph is y equals square root of x. What's y equals square root of x? Okay, half a sideways parabola, yes? Now, is it going to cross through this line it's rotating about?
No.
No, because it wouldn't cross through until like 16. Because at 16 it'd be 16.4. So my graph is going to look something like that, right? There is my y equals square root of x. And then y equals 0
X-axis.
is the x-axis. X equals 4
Vertical line.
is that vertical line. And the whole point of that vertical line is it's stopping, you know, that's where we're going, right?
What's the outer radius?
So here,
The outer radius is big R.
okay. So yeah, when they're asking outer radius, inner radius, we are being asked for big R and little r. Okay, that's what, you know, we're asking. Okay, speaking of big R and little r, let's talk, I don't know, something.
Y equals 4 to the axis is big R.
Right there? Okay, that's going to be the outside edge that is rotating around. When we write that as an equation, we are looking at upper minus lower, so we're thinking 4 minus 0. No, not for big R. We're going down to the x-axis, which the x-axis is y equals 0, right? So for the outer, it's going to be, I'm going to write it as 4 minus 0, which is just 4, yes?
Yeah.
Okay, what about the inner radius?
4 minus square root of x.
Goes from what we're rotating to our square root of x graph. So then we're going to be looking at 4 minus square root of x. Method?
Washer.
Yeah, they're asking is this disk or washer? We're rotating about here, and there's going to be this hole here. Okay, there's going to be a gap. Okay. V equals pi times the integral.
0 to
0 to
4.
4.
And question, which 4?
X.
The x's.
Because we're rotating around a horizontal axis, which is like parallel to an x-axis. So 0 to 4. What are you doing?
16 minus 16 plus x. Dx.
Not exactly, but big R squared, which is going to be 4 squared, which is a 16 he mentions, minus little r squared, which is 4 minus square root of x quantity squared, which is not 16 minus x, and then dx. Are you there? Okay. Now, before you integrate, we need to do some cleanup. What's Doug need to learn how to do?
Not make mistakes.
Foil.
He needs to FOIL, yes?
Yeah.
Okay, when he says 16 minus x, you've got to have a middle term in there. Now, this is going to be minus, right? Well, I'm gonna put it in parentheses, I guess, for the moment. So 4 squared is 16. 4 times minus square root of x is minus 4 square root of x. And there's going to be another minus 4 square root of x, which makes it
Minus 8 squared x.
minus 8 square root of x. Minus square root of x times minus square root of x is plus x. I'm going to do one more step before I actually integrate. I'm going to clean up. Oh, what happens? 16 minus 16 is gone. Minus negative 8 square root of x is going to be plus 8. I'm going to write x to the 1/2. And then what about this x?
Minus x.
Distribute the minus, so minus x. Now I feel like I've put myself in the position to integrate. Yes?
Yep.
Okay. Okay. Are you there with me on the 16/3 x to the 3/2? Add 1 to the power, it's 3/2. Dividing by 3/2 is multiplying by 2/3. 2/3 times 8 is 16/3, yes? Okay. Pi. Okay, x to the 3/2, so 4 to the 3/2. The square root of 4 is 2. 2 to the 3rd is 8. So whatever 16/3 times 8 is.
1/23.
Yes. Okay. Minus 4 squared is 16. Half of 16 is 8 for the moment. And then in those parentheses, minus, what do we notice? It's both 0 to power, so 0 minus 0. So I have the 128/3. I wrote it down from last time. In order to subtract 8, we should think 8 in terms of thirds.
24.
Mm-hmm.
I was way behind.
Oh, it's 124 thirds.
No.
104 thirds.
1.45.
Yes?
I was getting there.
And the best thing you can do for yourself is practice a little bit, you know. That's why I try, and sometimes I turn off my voice and just work and let you guys work, and we'll meet in the end. Okay. Got a little idea? Okay. Question 2? No, that was question 2, I guess, officially.
Question 3.
Question 3. The next question, whatever. Come on. There we go. Okay. Y equals 4 minus x squared. Y equals 0. About the line, y equals negative 1.
Upside down parabola. The top is at right.
Right? 4 minus x squared. Negative x squared is upside down parabola. The positive 4 means that it goes up 4. Right? Are you with me there? Y equals 0. Well, I guess I probably drew too much of that parabola, really. What is y equals 0?
The x-axis.
That is the x-axis. And so what is our region?
0.
In other words, well, in terms of what is our region, it is that top piece only, yes? Because y equals 4 minus x squared is the upside down parabola. Y equals 0 is the other border. So now, I'll be honest, if I look at my notes, I don't have the rest of this parabola written in here. Does it matter if it's in there? No, because I've shaded and I know this is what I'm rotating. Okay, but if you want to take that parabola out, by all means, you can, take that out there. I don't know, is it going to be confusing if I leave it in?
Yeah.
Hopefully not. Okay. With this in mind, let's see. She's claiming washer. Because there's this little gap right here, yes? Outer is big R, inner is little r. So big R is going to go from my topmost curve down to the line I'm rotating about, yes? So what are those pieces? On 4 minus x squared is my upper, and then minus the negative 1.
So that's 5 minus x squared.
Yes. Inner radius.
1.
0.
Okay. 0 minus negative 1. Which is indeed 1. Okay? As we set this up, we'll discover there's one piece of information we haven't talked about. The bounds. What bounds do I need? Where am I looking?
Gotta go find them.
Okay. I need my x's,
-2.
which are going to be right here and right here. Yes? Because we're rotating around the horizontal axis, so I want my x's, so I want the farthest left and right x values that we're going to use. Now, what's that mean here? Yeah. Could we set 4 minus x squared equal to 0? Because that's what's intersecting there, yes? So if you do 4 minus x squared equals 0, 4 is x squared, x is plus or minus 2. Also, if I had gotten specific and graphed my parabola, what's a parabola do? The first set of points go over 1, down 1. The next set of points would go over 2, down 4, and those would land there, wouldn't they? I just didn't get specific in graphing my parabola. So this point is 2, 0. This point is -2, 0. So my bounds are -2 to 2. Can you make it symmetric? If I look at my notes, hey, guess what I did on the next step?
Made it symmetric.
I made it symmetric. Okay? Because when we make it symmetric, what are we going to be able to do?
Use the zeros.
You're going to be able to do 0 to 2, and then out front you'll have a 2 pi instead of a pi. You don't have to, but it makes, you're realizing when you have to evaluate by hand, it makes the evaluation trick easier, doesn't it?
Yeah.
Okay. Big R squared minus little r squared, so
5 minus x squared minus squared
5 minus x squared squared
minus 1 squared
minus 1 squared
dx.
dx. So we changed it to symmetric. Again, you don't have to, but it makes the math easier when you're doing it by hand. Are you cleaning this up? Doug's spoiling this time, right? Okay, I think I'm ready to integrate. Do I agree with myself? Once I subtract the 1, it's 24 minus 10x squared plus x to the 4th?
Sure.
Or am I doing the work and you're just copying?
Sure.
Not going to lie, today is the copy day. Oh my gosh, Mario.
As I look at what I'm going to have to plug into, I think I'm really glad we changed it to 0 to 2 so that we don't have to plug into
All of that.
2 and -2 into all that. So plug in your 2.
That's 2. That's 2. That's 2.
I heard a calculator come out. Someone's cheating out there.
It's Doug.
I'm checking my answer.
It's Doug.
I already have a final, but I'm checking.
Because he did the work. He's not just going.
Yeah.
Is this really, am I right on this? Comment on there 15 now.
That's what I got.
Yeah.
Okay.
Now let's go there.
I'll meet you in the end, Mario. So, off to the side. Ugh. 48 times 15, really?
Oh, 8 times 5.
I'm just doing this by hand to prove it can be done, folks. Where there's a will, there's a way.
720. I did it. Good job, Mom.
And honestly, a couple of these, really the 720 is the only one I need to do in my head. The others I could, or on paper. The others I could do in my head.
I did not get 400.
80 times 5?
I did 80 times 18.
Why 18?
I don't know. I just.
We're going for a common denominator of
I don't know.
15.
I don't know.
3 times 5 is 15. 720 minus 400 is 320. 320 plus 96.
No, even.
Oh my god, I need to multiply by 2. This is so stupid. Alright. I got that before. I just wanted to do
How often is it we get a nice stuffy place?
Not very.
Our last time.
Okay. So, we got the first half of the lesson done. Those were all horizontal axes of revolution. That means tomorrow,
Vertical.
vertical, so we'll be working in Y's. Okay? Pretty much.
Whoa!
I see some calculator problems tomorrow.
Whoops.
So.
I honestly wouldn't even be mad if we were outside.